Lesson 93, fraction bars as symbols of inclusion. Remember symbols of inclusion? Which symbol of inclusion did we deal with the most? Last week, I believe it was. The parenthesis. What's one more example of a symbol of inclusion in math? Anyone? How about a brace, because they're the most fun to draw, especially on my digital drawing tablet. What about a fraction bar? It's not the local joint where 2/3 and 5/6 hang out after work. It's the little line in a ratio to show rational form. 2/3, that's the fraction bar. Kind of looks like a bar, right? Okay, that's a good review of some terms. Five times 4 divided by 2 times 4 plus 2. What's the acronym that has a lot to do with a problem like this one if we want to simplify? What's that acronym? Starts with a symbol of inclusion, parentheses, exponent, multiply and divide. You can do that if you want. Add, subtract. Do that if you want. Right? Tells us our order of operations, that we simplify within symbols of inclusion first, then we simplify exponents and roots, multiply, divide, add, subtract. Okay, so we see symbols of inclusion the way this is written right now. So we're going to simplify within this first. Of course, it's 20. Let's keep our parenthesis for now. Still divide. Within this parenthesis, this is 8 plus 2, 10. Now we finish by 20 divided by 10 is 2. This problem could be formatted another way. It could be formatted to show 5 times 4 on top of a fraction. And the bottom, again, 2 times 4 plus 2. What's the major difference in the way this is showing the same problem? We showed it as a fraction instead, because the other thing to remember about a fraction bar is it implies a certain operation. It implies division. Normally you would think, okay, do all division before any addition, but we think of a fraction bar as a symbol of inclusion. It groups these without having to show parentheses. These are implied when you use a fraction bar. We solve it the way we did before, even if there aren't parentheses. And that's why, and maybe you've never even thought about this, we're not trying to divide. Let's say next step, we got 20 over 8 plus 2. We don't try to divide this first because division comes before addition. That's silly. Because, well, the way it's explained, it's because when this fraction bar is here, it's implying we have a symbol of inclusion, yet we need to solve this to be 10. Then we divide and equal 2. So let's try one problem, and then you can prove to me this is as easy as you think it is. Simplify the following expression. If a fraction bar is a symbol of inclusion, what's implied that's not shown, not expressly shown, there is, in a way, parentheses around numerator and denominator. Solve within the numerator first, then the denominator, then finish with the division implied by the fraction bar, okay? Get rid of all this extra junk then. First step, P, right? PEMDAS. Just going to remind ourselves we have this right here. So 4 minus 3 times negative 4 plus 3 times 2. Why don't we do that right now, 2 plus 6. Keeping all our symbols together yet. That's all over what denominator? We've got like terms here. So 2 times negative 4 minus 1 is... Check my work. All right. We don't start dividing this out because, again, this is an implied symbol of inclusion. Solve within the numerator first. I'm worried I'm going to get cut off, so I'm going to work up here, maybe top right. Now we can multiply -3 and -4. What am I going to get on the top now? 4 plus 12.